Okay, so welcome everyone to the NPTEL course on Food Science and Technology, which is instructed by Professor H.N. Mishra, who is in the Department of Agriculture and Food Engineering. He is a professor who is the instructor of this course, and I am Shikha Sharma. I am teaching assistant of this course, and I am a research scholar in the Department of Chemical Engineering, IIT Guwahati. So I am the TA of this course for this January 2026 semester. So this is a live interaction session for week 3, and the assignment deadline for week 3 is 11th. So please submit your assignment on time, all the assignments on time. So in this interaction session, we will be basically discussing about module 3, and we'll be solving some of the assignment problems regarding it. Mainly today also we'll be discussing theoretical questions, and if you have some doubts, you can please feel free to ask. So in module 3, we have the topics related to major chemical processes in food. So it includes major chemical and biochemical reactions during food processing, handling, and storage. Then chemical interactions among major food constituents like the carbohydrates or the proteins and the lipids, and then the hydrolysis and the oxidation reactions, which are both the enzymatic one and the non-enzymatic one, and then the factors affecting the changes during processing and storage, and enzyme catalyzed reactions. So it includes lecture videos from 11 to 15. So I hope you have all gone through all these 5 lecture videos. So let's begin with our tutorial questions. The first question is about for the manufacture of caramel color in beverages, glucose syrup is treated with. First option is dilute sulfuric acid and neutralized with ammonia. Second is sodium chloride and heat. Third is acetic acid and heat. Fourth is hydrochloric acid without neutralization. So anyone who would like to answer this question? Anyone who would like to answer this question? The Rama Govind is saying A, which is dilute sulfuric acid and neutralized with ammonia. Okay, let's see. So this type of reaction is basically the caramelization reaction, where we are uh, using the sugar in the dry conditions, or we are using their syrups. So it will be heated, these sugars will be heated, and it will go under number of the reactions, like it basically the caramelization reaction, or if there is protein or amino acids are also there, then it can go under Maillard reaction also. So it depends on which temperature we are processing and which type of catalyst we are using. That based on the catalyst and the temperature, it can undergo any reaction when sugar is being heated. Generally, basically, there will be reactions which will lead to the equilibrium condition or equilibration of anomeric and ring forms, and also the inversion of the sugars, then condensation reactions leading to the formation of oligosaccharides and the polysaccharides, then isomerization. Basically, what is happening is uh, these all reactions, which is isomerization or whatever is happening, like we are forming the condensation reactions or the inversion of the sugars or the dehydration and the fragmentation, they will occur. So they will lead to the formation of the unsaturated polymers which will have the brown color. So this brown color is we can see. So if we are using some catalyst, so it would be possible that we can conduct this caramelization reaction. So this caramelization reaction is used for the food, for providing it with the flavors and the color, the caramel color or the caramel flavor basically. So here we can see that this is the ketone group basically. So the ketone group basically is undergoing uh, the enolization reaction, and it will form enol here. So this bond will break and H will going to attach, and this reaction is called basically enolization. So from this picture, we can see that when sugar, when it is just at 160 degrees Celsius, its color is little pale, but it's not very dark. But when we increase the temperature, so this color of the sugar, it becomes darker, like from 160 to 168, then 173, and then 180 and 185. So the color is becoming more and more dark. Also, like we can see here, so there are different syrups which is having sugar and water and additives. So what is happening when we are heating these syrups up to 148 degrees Celsius, then the caramelization reaction is happening for the sugar. So this is lime juice which is under basically the reaction is taking place under the acidic condition, and this is the baking soda. So means that the reaction is taking place under alkaline condition. So we can see if we change the pH, so the color is also very different for the caramel browning. So the industrial process of manufacturing basically the caramel color for the beverages, it basically includes that we treat the glucose syrups with the dilute sulfuric acid, and it will be catalyzed, and it will form like the caramelization reaction takes place, and the basically it depends, the color depends on which condition we are putting, like if we are putting the acidic condition or if we are putting the basic condition. So and the resulting acidic environment is partially neutralized with the help of ammonia to control basically pH and prevent the excessive degradation, because if more acidic condition will be there, so the more degradation will be there. So basically the pH is neutralized with the help of ammonia. So here basically this question is saying that in that glucose syrup basically is treated with the dilute sulfuric acid, and it is neutralized with the ammonia to get the caramel color in the beverages in the industries. So this option first is correct here. So when sugar is dried, it is basically heated and it will come to a colorless liquid. But when we heat it up to very high temperature around 150 degrees Celsius, so it will develop some brown color and also the characteristic aroma or the flavor. So that is a caramel flavor. So caramelization basically it is halted or it is inhibited. This reaction can be stopped by adding the water. So when we get the desired color or desired flavor, we can stop the reaction by adding of the water. So sugar basically here is break down during the caramelization, and various organic acids it will form. So in this, by this reaction, we can achieve desired color and the flavor for our beverages. So there are some examples of caramelization reaction, and here it is saying that there are different products like black tea leaves. So here it is it is saying that black tea leaves we fire, and firing used for halting fermentation causes basically caramelization, which gives some characteristic color in this black tea leaves. Beverage in the beverages, caramel basically is used, and it will give dark to little brown color. In ghee, when butter will boil up to 90 degrees Celsius or 120 degrees Celsius, so the particles basically it will becoming brown and it will give some kind of a caramel aroma. Then we clarify basically finally the ghee. Also in khoa, we can see slight brown color and white color like uh, basically if we prepare kalakand or some other sweets, so we can see caramelization. And in chicky also, where jaggery solution is basically we heat it to very high temperature around 130 degrees Celsius. So it imparts the mild caramel flavor and also it imparts some brittleness. So this is the basically desired reaction, chemical reaction, which occurs in the food and it is basically desired because we want to get certain kind of aroma and also color. So is this question clear? We are moving to the next question and the person who is unmute, can you please mute yourself? So match the reaction type which is in column 1, the Maillard reaction, lipid oxidation reaction. Third is enzymatic browning and fourth is caramelization. In column 2, we have the suitable reaction inhibitors. So antioxidants like vitamin E, B is reducing pH and temperature, C is using non-reducing sugars like sucrose and D is reducing oxygen exposure. So anyone who would like to answer this question? Anyone who would like to answer this question? That Aman C, Satyam C. Okay, let's see. So here answer is first, and let's understand why. So basically, we have two heat-induced reactions, which are non-enzymatic. Basically, two reactions. This is the caramelization reaction and the Maillard reaction. They both are non-enzymatic browning reactions, and they are both basically heat-induced reactions. Caramelization reaction we just now discussed in detail that there is the thermal decomposition of the sugars because of the high heat and we can slow down or we can change the reaction or we can get the desired color by maintaining the pH and the temperature. So when we have the low temperature and we have the acidic condition that we can inhibit the reaction of caramelization reaction. So it, sorry, fourth, which is related to B, which is this, when we are reducing the pH, which is acidic pH, and we are reducing the temperature. So the caramelization reaction, it will halt, it will inhibit because the caramelization reaction, as we see here, it takes place at very high temperature around like 160 to 180, you can say it takes place. So at low temperature, this reaction will not going to take place. So it will, this temperature, low temperature will halt the reaction. Also, when we are using, basically, we need to control the pH in the caramelization reaction. So if we have the high acidic environment, so what we do, we basically neutralize it with the ammonia so that the pH will be in control. Otherwise, the reaction may stop. So we need to maintain the acidic condition also. Like the lower acidic condition basically can inhibit. So basically, we need to maintain a proper pH here. So it should be under proper pH condition. So to maintain the pH, we can use some acidic condition And also we can, if the acidic condition are too high, we can use ammonia to neutralize. It basically depends on which color, like how much darker color we want to get. Then second is the Maillard reaction. This Maillard reaction is also basically non-enzymatic reaction which depends on the heat. So it basically involves basically the reaction between basically sugar. So the carbonyl group of the sugar will be taking part in the reaction with the amino acids here. There it's just the sugar. In the caramelization, it's just the sugar which we are heating, but here we are using the amino acid, which is a protein. Also it will react with the sugar carbonyl group, and it will produce brown color, brown black color. So the condensation product of sugar and amino acid, it will undergo enolization and rearrangement, and then undergo the condensation, and the polymerization will form the red brown color or dark brown compounds. So this occur basically at low temperature than the caramelization temperature. The caramelization will going to occur even at higher temperature. In this, there are three steps. First, there is a formation of N-glucoside. So here from the glucose, T-glucose, basically this amino group is reacting, and it will going under some reaction, and it will form in the first step this basically glucosamine. Then after this N-glucoside will form, then ammonium ion is formed, and then it will basically isomerize, and it will undergo basically amidary rearrangements, and then finally there will be compound we get known as ketosamine. So we're going to get this ketosamine group. So this is basically this. From this, second step is this. So here the compound is undergoing some kind of rearrangements, which is known as amidary rearrangement, and finally we are getting this product which is basically ketosamine. Then this ketosamine, basically this product, it will either dehydrate, which means removal of water, then it will dehydrate into reductons and dehydroreductons, which are caramels. So it may undergo uh, the dehydration and form caramel, or it can produce short chains hydrolytic fusions product such as the diacetyl, acetol, and pyroaldehyde, which then undergoes the Stracker's degradation. So finally, the compound which we'll get from this reaction is this, which is malanoids. So malanoids are having this red brown color. It will give that this color through the Maillard reaction. So Maillard reaction, basically it can be inhibited when we keep the pH of the food below isoelectric pH of the amino acid, because if this pi this isoelectric pH, basically if it's less than the pH of the amino acids or peptides or the protein which are present in the food, like which the food's pH is less than the isoelectric point, then what will happen? These amino acids or the peptides or the proteins, the structure of these will denature and it will collapse, so it will lose its functionality. So because of low pH, it may the reaction may not follow, because here we need protein also to carry out the reaction, or the amino groups to carry out the reaction. So if the functionality of the amino acids will lose, we cannot carry out this Maillard reaction. Then second is we need to keep the temperature of the processing as low as possible during the processing and storage. So if the temperature is low, then it can halt, inhibit the Maillard reaction. Then third is use of non-reducing sugars. If we are using non-reducing sugars like sucrose we are using, which is not having this carbonyl group, C double bond, O is not having, if like ketone group is not having or carbonyl group is not having, so it will not favor the inversion reaction. So Maillard reaction cannot take place. Next is if we are using sulfur dioxides or sulfides, which inhibits basically browning. So in these cases, we cannot use the Maillard reaction. So here Maillard reaction we cannot use when we have the non-reducing sugar like sucrose. So it will inhibit basically this reaction. So in the food, this reaction will not going to proceed. Then basically lipid oxidation is basically a process that leads to the development of the rancidity or the off flavor and is basically effectively prevented by the antioxidants like vitamin E. So vitamin E act as an antioxidant basically to so that the lipid oxidation will not happen and the rancidity or the rancid flavor or will not get. So it basically neutralizes the vitamin E neutralizes the free basically radicals, or it prevents from the oxidative damage. Like we have the PUFA, which is the fat. So if we have oxygen, it will be in direct contact with oxygen. It can undergo lipid oxidation. So it may form lipid peroxidase or such products. So basically, if it will react with reactive carbonyl species, we can get some free uh, reactive carbonyl species metabolites, which can be further basically we can detect or we can analyze and we can understand that okay, this uh, if it is we are getting this kind of products, that means the lipid oxidation is taking place. Also there may be some non-enzymatic conjugates formed during the lipid oxidation. So uh, basically what is happening in the lipid oxidation, there are three steps happening. Like first is the initiation of the uh, like initiation or the free radical formation, and then its propagation, and finally its termination. So in these three steps this reaction takes place and lipid basically it goes under oxidation. So lipid oxidation is basically related to this. If antioxidant like vitamin E will not be there, so the reaction can undergo lipid oxidation. Next is the enzymatic browning. So which occur basically in fruits and vegetables, because in fruits and vegetables we have enzyme like PPO, so polyphenol oxidase. So what this will basically, this will carry out the reaction and convert the phenolic groups basically into the quinones, and finally the melanoids or melanins will produce, which is in the brown color. So this is basically the enzymatic kind of oxidation, because this enzyme PPO will going to carry out the reaction. So it can be basically stop, this reaction will stop if there is no oxygen, because polyphenol oxidase, it is in the presence of oxygen, it is carrying out this reaction. So if oxygen will not be there, so this reaction cannot take place. So we can prevent the enzyme from catalyzing the reaction if we have the vacuum kind of condition uh, for our food storage. So if we see here, enzymatic browning, it is related to reducing the oxygen exposure for stopping the reaction. So here is the first, picture A is basically telling that the unsaturated lipids which are present in like the fish. So under the photo degradation condition, it will form radicals. That radicals will propagate, and the finally the reaction will take place, and it will form some kind of the rancid flavors or the flavor compound. So this is the lipid oxidation reaction. And second is the this one we discussed already, which is the enzymatic browning reaction, which need oxygen to carry out. Okay, so if we see the reactions in the apple, so there's catechol or monophenol, they are basically the flavonoids group, or they are basically the polyphenolic groups. So the polyphenol oxidase, this basically enzyme will form like this, convert this into orthoquinones. Here also orthoquinones, and further the reaction will take place and melanin will form, which will lead to browning in the apple. So this melanin formation basically it's not desirable in the fruits and vegetables. So uh, basically we need to inhibit it. So heat treatment and application of sulfur dioxides or sulfides can inhibit it, and also irreversible inactivation like the pH less than 3 by adding the acidulants or organic acids like citric acid or the malic acid or the phosphoric acid. And also we can exclude oxygen from the reactive side by immersing the tissues in the brine or the syrup, or some kind of the vacuum we can form like vacuum packaging to inhibit this kind of reaction. Then fourth one is that we can protect the phenolic substrate basically by use of the certain enzymes, so which modify basically orthophenolic substrates. So these are the ways we can inhibit the enzyme action. So mainly we can use this, and we mainly this enzyme phenolase will also be there. So basically the uh, this will going to carry out the reaction polyphenol oxidase also. So it will form orthoquinones. These kind of class of the enzymes will form orthoquinones, and finally the melanin. Okay, so answer of this is basically A here. Let's move to the next question. So now we are discussing Arrhenius equation, which describes the relation between the reaction rate and which one? Pressure, or the concentration, or the temperature, or the light intensity. Anyone who would like to answer this question? C, B, okay. Concentration, temperature. Mostly we are getting C or B. Okay, let's see Arrhenius equation and its relation. So basically, the answer is temperature. So basically, Arrhenius equation is basically the relation between the rate constant, which is K, with respect to the temperature T. So it tells how much is the rate constant, or the rate of the reaction is increasing when there is a change in the temperature. So mathematically, we know, we write the equation, this is K equals to A, which is Arrhenius constant, or sorry, which is basically K is the rate constant here, and A is the pre-exponential factor, and then exponential minus EA, which is activation energy, by RT, which is gas constant and temperature. So here is a relation between temperature with respect to the rate of the reaction. So, or rate constant of the reaction. So this here is a basically relation between reaction rate and temperature. So if we plot this, um, so if we plot, we'll take log both sides here. Log K equals to log A plus, but here it's minus, so we'll take minus log. So basically it will be log EA minus log RT. Or if we write it like this, so log E by RT. I'm so sorry. It will be log EA by RT. So here it will be minus. If we are using here plus. So if we use this equation, so what will happen? This is the log K and we are plotting against 1 upon T here. So here log E will with we are taking L, if we are taking ln, so it will be ln K here equals to ln A, then we will have minus because this E will cancel with ln, so minus EA by RT will get. So if we plot with ln K and 1 upon T, so we'll get this kind like this equation because this is minus, so this is decreasing. So and ln A will be intercept here, so intercept will be ln A, ln K will be on y-axis, 1 upon T on the x-axis. And the slope of this equation will provide the value of minus EA by R. So this is the Arrhenius equation. So this relationship basically it demonstrates the relation between the temperature. So if the temperature is increasing, the rate constant it will increase, causing reaction to proceed faster. Okay, let's discuss this question. Which of the following process is more likely to deviate from the Arrhenius relation at extreme temperatures? The protein denaturation, starch gelatinization, lipid oxidation, and Maillard reaction. So anyone who would like to answer this question? Anyone who is answering this question that when we have this Arrhenius relation at extreme temperatures, maybe very low temperature or very high temperature, so which reaction will going to deviate? Protein denaturation. Okay. Okay, let's see. So yes, protein denaturation is the correct answer. So basically, when we are having very like extreme temperatures or very high temperature or very low temperature, the Arrhenius relationship will be deviate for the protein denaturation because we know that the functional property of the protein when we have different temperatures, like when we have very high temperature, or when we have where like it will when we are deviating from the optimal pH or the optimal temperature, so the bond will disrupt and the protein will denature and lose its functionality. So when we plot the log, like log of the reaction rate with respect to the temperature, so this will be, if we have the non-enzymatic reaction, then the variation will be at extreme temperatures here and here. Also, when we have the enzymatic catalyzed reactions here and here, if we see, there is the variation, like it's not the straight line, deviation will be there. So basically, Arrhenius equation describes the exponential increase in the reaction rate under some temperature. Uh, so it basically tells that exponential increase in reaction rate will be there if the temperature is under some assumption condition and the reaction mechanisms basically remains constant. But when we have the protein denaturation, so it involves basically the complex structural changes such as the denaturation, which includes the unfolding and the aggregation of the protein, so which will not going to follow a simple temperature dependent mechanism. So at extreme temperatures, basically the protein's 3D structure, basically it can undergo abrupt and irreversible changes, leading to a sharp decline in the reaction rate rather than a continuous increase. So when if we see the basically starch gelatinization or the lipid oxidation or Maillard reaction, so they will basically follow Arrhenius relationship more consistently rather than this protein denaturation, because of the change in 3D structure of the protein or the denaturation of the protein. As these reactions basically do not involve complex conformation shifts, so that alters the reaction pathway in a non-linear fashion. So these reactions like the starch gelatinization or the lipid oxidation or the Maillard reaction will not affect much, whereas the protein denaturation will going to affect a lot. So deviation from the relationship can occur because of the loss of the enzyme activity. So enzymes basically are the proteins only. So the when we have we are carrying some of the reactions, so these enzymes they will denature, or they are the proteins only, so they'll change their structure and they'll lose their function. So the rate of the reaction will change. The second is reaction pathway or rate limiting steps may change or may be influenced by competing reactions. Third is the physical state of the system may change. In the freezing, so in freezing, am I visible? Am I audible also? Is the screen visible? Is this working fine? Okay. My connection was interrupted for a bit, so I thought, okay, so recording is on. Yeah. So when we have very low temperature, like we have the freezing temperatures, so what will going to happen? The Arrhenius equation will not going to follow, because the state of the here, if we see very, because this is 1 upon T, right? this x-axis is 1 upon T. So basically, at very low temperature, what will going to happen? The state of the product will be different. It will be in solid form. So basically, its reaction, or basically the enthalpy we are using, del H, it will change and will not have the different. Basically, Cp will also vary here, specific heat. So will not have the same kind of the reaction rate when we are having in the normal temperature range. Also, one or more reactant, if it may deplete, then rate of the reaction may also change, and it will not follow Arrhenius equation. So here in this question, answer is protein denaturation. Basically, at the time of protein denaturation, we have the deviation we can see. Next question is about the pigments, basically. So which of the following statement is true about the color change in the cooked green vegetables? So we have the three statements, like the change from the bright green to dull olive brown is due to the conversion of the chlorophyll to pheophytin under acidic conditions. Second is interaction of chlorophyll with flavonoid compounds. Third is basically blanching vegetables in alkaline water and can help retain their bright green color. So it's this question is mainly about the degradation of the pigments, basically. So it is, this specific question is about for chlorophyll. So we need to tell which statement is true about the color change in the cooked green vegetables. Anyone who would like to answer this question? C, which is 1 and 2. Everyone. So we got three answers, and Fozia is saying D. Rest others are saying, like Jitendra saying, Gautam is saying C. Neha is saying D. So we are confused between C and D. Let's see. So C is the correct answer here. Let's understand this question well. So the color change in the cooked green vegetables, it can be from bright green to dull olive brown due to different chemical reactions. So basically, the bright green color is because of the chlorophyll present. So this chlorophyll pigment basically is responsible for the vibrant green color. So when there is this loss of the magnesium iron under acidic conditions, this will convert into pheophytin and it will produce this dull olive brown appearance. Like if we see here in this reaction, so this chlorophyll B is basically converted into chlorophyll A, which is a green color. Both are green color. Even if we have chlorophyll B in our like fruits and vegetables, or if we have chlorophyll A, so it will both is green in color. But if chlorophyll B is there, so chlorophyll B will convert into chlorophyll A with the help of reductase enzyme, and still it will be green in color. But if this magnesium will remove from this, from the structure of chlorophyll, so we can get this in the under the acidic condition. So we will get the compound known as pheophytin, which is olive brown in color. So because of this, the color will degrade of the chlorophyll. So we can see, like, this is a canned product basically. So the acidic environment basically in cooking often cause by the natural release of organic acids from vegetables. So it accelerates this transformation. So if the acidic condition will be there, so the magnesium release will be more fast and pheophytin we can get and the color will be dull. So to prevent this, what we can do is we can do first is blanching. So blanching vegetables if we are doing in alkaline water, so the pH we are increasing. So it may uh, reduce the uh, change of this pheophytin and we can maintain their bright green color. So the alkaline condition basically it will prevent or slow down the conversion of chlorophyll to pheophytins because it will neutralize the acids which are produced during cooking. This helps chlorophyll remain intact and produce the vibrant green hue for the vegetables in the vegetables. But if there will be excess alkalinity, it can also negatively affect the texture. But second option, what we can do is we can convert into this chlorophyll into chlorophyllide. So which is basically a more stable group. So basically this phytol group which is present in chlorophylls basically is removed by the enzyme chlorophylase and it will produce this basically chlorophyllide. So basically this is a bright, its color is bright green. So if we convert this reaction, so we can get a good color of the vegetables. So the interaction of chlorophyll basically if we are converting into this chlorophyllite, so we can get bright green color. But what happen if the magnesium in chlorophyllates, basically if it's removed, then what will happen? It will convert into pheophorbyte, which is again olive brown color. So the color will going to be dull olive color, dull color or olive brown color. So and also further reactions will make the vegetables colorless also if it's at extreme. So basically if possible we can stabilize the color of the vegetable by this compound. But if it undergoes this reaction, then we cannot stop to change the color and the color will degrade. Then the interaction of basically chlorophyll with flavonoid compound, basically it doesn't play any significant role in the color change of the green vegetables. So flavonoid color, flavonoids basically affect the color stability with the pigments like anthocyanin only, and with chlorophyll, flavonoids has no much interaction, but pigments like anthocyanin, it has interaction. So in the chlorophyll degradation pathway, where pheophytin is forming, this flavonoid is having no direct impact or direct effect. But flavonoids, basically the flavonols like quercetin, glycosides, rutin, they act as a co-pigment and they interact with the anthocyanin, flavium cations or other quinoid spaces and it will form non-covalent interaction like pi-pi stacking and hydrophobic effects and they will form some complexes. So that will basically reduce the hydration and it will basically reduce the change in the color changing happening which is going from color to colorless. So it will limit this degradation, but not in chlorophyll. So basically change from bright green to dull olive brown is basically due to the conversion of the chlorophyll to pheophytin under acidic condition, which is true. Then blanching vegetables in alkaline water, it can basically retain their bright green color, which is also true, but the interaction on chlorophyll with flavonoid compounds is not there. So basically second is not correct. So answer D is correct here. I'm so sorry, but answer D is correct here, not C. Because 1 and 3 are correct, not 1 and 2. So D is correct here. I will make the changes in this PPT accordingly. Okay, let's discuss another pigment decoloration question or pigment related question. Anthocyanin color change in food system basically are influenced by first metal ions such as copper or iron, which can accelerate oxidation. Second is pH and temperature, leading to structural transformation and color shifts. C is hydrophobic interactions with lipid molecules, stabilizing the pigment. D is interaction with polysaccharides, preventing color change under acidic conditions. So we need to tell about the anthocyanin color change, which factor is affecting. Anyone who would like to answer this question? Fozia is saying B. Anyone else? Okay, let's discuss this question. So she's correct. B, that the anthocyanin color change in food system basically are influenced by pH and temperature. So it leads to the structural transformation and color shifts. So anthocyanin basically is very highly reactive compounds, and because there is this flavium nucleus is there in the structure, so because of that it is very reactive. So anthocyanin basically this pigment are highly sensitive to pH and temperature. So we can see in the red cabbage anthocyanin, and the neutral it is little purplish color, but whereas in the alkali condition it is green, and if we do the acid test, so it will be red in color. So because of the change in pH, it is highly sensitive to it and it is changing the color. So low pH, basically anthocyanin appears red, but at the high pH, the color shifts to basically purple. And if further pH high will be there, then blue, because of the structural conformation changing, or structural transformation is there of the pigment to quinoidal or anhydro bases, and then to the carbinol bases. So carbinol base basically is colorless and fairly stable, but it decomposes slowly upon standing. So if we keep like this, so it'll this carbinol base it'll degrade. So this compound, this anthocyanin, basically is very sensitive to pH and temperature, and because its structure is transforming and the color is shifting. So if we see the reaction, so if the pH is changing, so what is happening to the structure of the anthocyanin? So that results in the color. So this is basically flavium cation, which is at less than 3 pH, it is red to orange color. So it will basically, when the pH will be more neutral, like 6 to 7, it will be purple to violet color, because it changes the structure and it will form in quinoidal bases. And at 7 to 8 it shows blue color, because here it is in anionic quinoidal bases. So at 6 to 7 it is neutral, but here it is more anionic. so it becomes blue. So when pH is 4 to 5, it will become colorless because of the presence of carbonyl group, and also it can convert, like if the pH is very high, greater than 8, it may convert into chalcone, which is a colorless, also a colorless compound. So based on the pH, this anthocyanin is changing its color. That's why this anthocyanin is basically nowadays used in the smart or basically intelligent kind of packaging technologies for the preserving of fruits and vegetables, because it changes its color and it can produce some signals based on changing of the pH. So if the microbial attack is there on the fruits and vegetables, that means its pH is changing, right? So if the pH is changing, the color of anthocyanin will change, and it indicates that the product is spoiled now. It's very useful compound. So next is phenolase oxidize, basically. So what happens is, because of the change variation in the pH, and so this anthocyanin basically is of different color. So it has basically of different compounds are there in this, which comes under this class, and it has different colors based on the compound name. So phenolase oxidize orthodihydroxyphenol and catechol to orthoquinones, which then oxidizes the anthocyanin non-enzymatically to the colorless colorless compounds. So next is the peroxidase, also can convert the anthocyanin to the oxidation products and can bring decoloration. So these are the decolored or the colorless products also. So we can have different compounds based on that different. We can have color based on this UV spectra. So more violet color is there in the malvidin, and more reddish color is in the cyanidin. So there are different colors of this. So we can have different compounds or different colors based on the pH also. So here this answer is correct, that the color is changing basically due to the structural conformation is changing. Temperature also basically affects this anthocyanin stability. So with basically high heat accelerating basically the degradation. If the high temperature is there, the degradation will be more in the anthocyanin. Also, if the metal ions like copper and iron is there, it can oxidize the reaction with the anthocyanin, and basically they degrade anthocyanin, and it can affect its color also through the structural transformation. So anthocyanin basically do not form hydrophobic interactions with lipids that stabilizes their color. Also, the polysaccharides generally do not prevent color changes caused by the pH shift. Instead, they may have a stabilizing effect through non-specific bindings, but not enough to prevent significant color change. So not because of the polysaccharides, much color is not changing much. And then sulfite and sulfur dioxides are there, so they can produce a bleaching effect due to when we are adding the sulfur dioxide at the position 2 or 4, there will be bleaching effect, so the color will go to the colorless or are quite stable color compounds we can get. And removal of the sulfide by boiling or the acidification, it can result in the regeneration of the anthocyanin. Also the ascorbic acid can react with anthocyanin and degrade of the both the compounds. So intermediate peroxides is produced by the degradation of the ascorbic acids, and it may responsible for the reaction with the anthocyanin. Also, accelerated instability of anthocyanin can be there in the presence of furfural or 5-hydroxymethyl or ascorbic acids or amino acids and phenols, may be due to the actual condensation reaction of these compounds or their degradation products with the pigment. So basically, interaction with polysaccharides preventing color change under acidic condition is not because with the polysaccharides it is basically not causing the pH shift, and it just form the like basically stabilizing effect it just provide with the help of non-specific binding. So there is no much effect in the color shifts. So in the this one last one, D option is not that important. Also, when we are using this copper and iron, then basically what is happening? So when we are using this copper and iron, it can accelerate the oxidation reactions, and the color of the anthocyanin color the compound can degrade, but the color the compound itself may degrade rather than influence their color spectrum. So the color spectrum through structural transformation is not there, but the compound of anthocyanin itself will degrade here. So here it is saying that accelerate the oxidation. It accelerates but not affect, like the influence on the color is not much, but degradation of the compound of anthocyanin is there, so it's not that important also. And lipid molecule hydrophobic interactions, it stabilizes a pigment, so it doesn't affect that much. So only B option is correct here. Okay, let's see this question about lipooxygenase. So lipooxygenase basically it stabilizes the aroma profile of food by interacting with unsaturated fatty acids. B, oxidize essential fatty acids leading to off flavors and potential loss of the nutritional quality. C, improve the digestibility and bioavailability of proteins in legumes. D is catalyze the reaction exclusively under extremely acidic or basic conditions. Anyone who would like to answer this question? Jitendra B, Fozia G, B. So you guys are saying that oxidized essential fatty acids and leading to off flavors and potential loss of the nutrition quality, which is correct. So this lipogenase basically enzyme, it catalyzes the oxidation of the polyunsaturated fatty acids, which are PUFA, and like the linoleic acid or linolenic acids, and it basically led to the formation of hydroperoxidase. So hydroperoxidase is basically it decomposes into the further secondary compounds like aldehydes and the ketones, which basically are responsible for the off flavors in the food. Like in soya bean, basically lipooxygenase activity, it contributes to the beany flavor, making the soya products less appealing unless the enzyme is inactivated during processing. So we need to inactivate the enzyme in the processing, otherwise we'll have the beany flavor in the soya bean because of lipooxygenase enzyme. Also, intermediate products like of this lipooxygenase, when lipooxygenase react with the lipids, it can form some intermediate compounds which can damage the vitamins and the proteins in the food. and this enzyme basically it can show the bleaching effect by oxidation of the natural pigments of the flour. So the white crumb bread, or to get the white crumb, sometimes lipooxygenase enzyme is desirably used to bleach the compound, or so that the like basically lipooxygenase is basically going to provide the white color to the flour, and which will produce a white crumb. So that's a desirable reaction. So it is basically used in the food industries to get the natural white pigment. So this is a lipid, basically unsaturated fatty acids. It can undergo the oxidation, like the primary product will be peroxides. The secondary products can be aldehydes and alkanils, and tertiary product it can form, which can be aldols and aldehydes or furan compounds, alkyl furans. So basically this, if we see the lipids reaction with the protein, so basically lipooxygenase basically is the enzyme, and it is reacting with the protein with the lipids. So it will oxidize the unsaturated lipids, which can form the alkoxy and peroxy free radicals, and these free radicals basically react with the protein further, and it will form lipid protein free radicals. These lipid protein conjugates basically, these free radicals, they can go under the polymerization reaction and cross-link with the protein, and it will form the cross-linked structure. And these lipid free radicals, they can also induce the formation of protein free radicals at cysteine and histidine side chains, which may then undergo the cross-linking and polymerization reaction. So this is a lipid. When it is going to the under oxidation, it will form lipid peroxidase, and it will basically react with then the protein nucleic acid, and it will form HEL, which is hexanoyl lysine, or basically this will form lipid and protein complexes, and that's how it will further this lipid or hydroperoxides basically in the foods, it will decompose and liberate the aldehydes and the ketones, and then these carbonyl groups basically they'll react with the amino acids of the protein via carbonyl and amine reactions. Skip and the skip base will form, and this reaction of the malonaldehyde with lysyl side chain of the cross-link polymerized proteins leads to the cross-linking and polymerization of this protein, and the further basically what is happening is there is this binding with the protein also, and forming different compounds or the different degradative or basically undesirable compounds with the when lipid will going to oxidize and further form the lipid protein compounds, which will basically not only affect the lipid content in the food but also affect the protein content in the food. If the protein content is low and lipid content also like it is oxidized, so the food will not have much of the nutrition value. And also because of the protein, protein can undergo some like form some compounds which can produce off flavors. So in this question, we have this lipooxygenase. Basically, it oxidizes the essential fatty acids, which leads to the off flavors, and potential loss of the nutritional quality, because lipoxygenase is oxidizing the fatty acids first, and because of the lipid protein complexes forming, so nutritional property is also getting low, and because of the rancidity, the flavor is forming. Also with the protein, lipid protein complex, some of flavors can generate. So overall the lipooxygenase enzyme, it is basically affecting the essential fatty acids and forming the off flavors and low nutrition food. Okay, let's move to this question. So in column 1, we have some oxidative agents like free radicals or the trace metals or the light exposure or the high temperature. And in column 2, we have its effect on the food. So it may accelerate oxidation reaction in lipids and proteins. B is breakdown of the chlorophyll leading to the color loss. C is initiates oxidative damage in proteins and lipids, and D is catalyzes electron transfer, enhancing oxidation. So anyone who would like to tell or share his or opinion on this question? Neha is saying D, Fausia B, A, and Jitendra B. B, A, and D. Okay, let's see answer. So A is correct here. So let's understand the mechanism of these all oxidative agents. So free radicals, they are basically highly reactive species. So they initiate oxidative reactions, and they initiate the oxidative damage in the proteins and lipids, and it can cause to the protein denaturation and lipid peroxidation. So it results in the off flavors and reduce the nutritional quality, as we can see in the rancid oils. So just now we discussed that lipid peroxidation. What is happening in lipid peroxidation? So lipid peroxidation, free radicals are basically acting, and they're acting both on the, like, causing the protein denaturation and lipid peroxidation and forming the off flavors and rancid oils. So if we can see, we discussed already in the previous slide. Here, so here if we see in the lipid oxidation, we know that the lipid oxidation takes place in three steps: initiation, propagation, and termination. So what is happening here? Free radical is attacking, and like free radical is forming, and then the like propagation is happening, and then finally termination is happening. So this is the lipid oxidation, how it's happening, right? So here LOO, this is basically LOO and dot, this is free radical. So this is basically peroxide radical is forming. So this way the lipid oxidation takes place, right? Let's see our question now. So free radicals is basically initiative the oxidative damage both in lipids and the proteins, because we have already seen how lipid peroxidation takes place, and how the rancidity in oil take place. So free radical is attached to initiation of the oxidative damage in proteins and the lipids. Then trace metals like iron and the copper, they are what they are doing. They will going to catalyze in the oxidation process, and they will facilitate the electron transfer and accelerate the oxidation reaction through the Fenton reaction. So what is happening here? Like trace metals like iron, Fe2 plus, what it will go do? It will react and go under the electron transfer reactions, and it will going to accelerate the oxidation, and here it will form the basically it will decompose this hydrogen peroxide, which is H2O2, into basically hydroxyl radicals. So it will form two hydroxyl radicals. So this hydroxyl radicals will going to produce the oxidative stress, or it will going undergoing the oxidative reactions. So this way it is working these trace metals. So it is related to D. Then light exposure, what it is doing, it is breaking down the sensitive pigments like the chlorophylls in the green vegetables. So it will reduce the color loss, and the color will be faded. Like spinach, its color can undergo dull, and it can lose its vibrant green color. So light exposure, basically it will break down the chlorophyll, leading to color loss. Then fourth is the high temperature speeds up oxidation reaction. So in basically high temperature, the lipids and the pigments, they will get the energy to overcome the activation barrier, and that way the spoilage or the browning reactions can proceed like in fried potato chips. So high temperature, it will accelerate the oxidation in the lipids and pigments. So answer A is correct here. Can we move to this next question about saponification? So which of the statement about saponification processes are correct? Statement 1 is saponification is a base catalyzed hydrolysis reaction where triglycerides, they will convert into glycerol and fatty acid salts. And second is saponification can occur in the presence of strong acids like the sulfuric acid. So which statement is correct, we need to tell here. So we got already few answers. Neha A, Gautam B, Fozia A, and Ankit also A, also Lakshmi A. So many are saying A and one of us is saying B. So okay, let's see. So A is correct here. So saponification is a reaction, or there's a process where there is hydrolysis of the triglycerides. This is triglycerides. Basically, it's when it will react with with a strong base like NaOH. So there will be the formation of glycerol and SOP. So SOP is basically fatty acid salts. Fatty acid salts will be there. So this is the saponification reaction. So statement 1 is saying that the saponification is a base catalyzed. Obviously, this is base catalyzed because sodium hydroxide is there, right? Hydrolysis reaction. Yes, this is an hydrolysis reaction. So where triglycerides is forming or converting into glycerol and fatty acid salts, which is correct statement. Second is saying that saponification can only occur in the presence of strong acids like sulfuric acid. No, whereas we need the base for its reaction, not the acid. So statement 2 is incorrect. Is this question clear? Can we move to this next question? We have in column 1 different food dispersions like emulsion, suspension, foam, gel. In column 2, we have its characteristics like dispersed gas bubble in a continuous liquid phase. B is solid particles dispersed in a liquid medium. C is liquid droplets dispersed in another immiscible liquid. D is a semi-solid structure with a network of polymer chains trapping liquid. So this is a very basic question, that we have different food dispersion systems, types of food dispersion. So we should know Which one of which one is known as the gel or foam or suspension or emulsion? Okay, so Jitendra is saying A. Lakshmi C. Aman C. Ankit C. So most of us are saying C here. Let's see. C is the correct answer. So basically, an emulsion is a type of dispersion where we have the liquid droplets are dispersed in another immiscible liquid, such as oil in water or water in oil. So we have like mayonnaise or the salad dressing. So what happens? So if we say this is like a emulsion. So here what is happening? Either two immiscible liquids are there, they are dispersing, right? So either the oil in water system can be there or water in oil emulsion can be there. So this emulsion basically is related to the liquid droplets dispersed in another immiscible liquid. Next is suspension. So suspension basically refers to a system where solid particles basically are dispersed in liquid medium, such as muddy water or flour mixed in water. So these particles, they can settle down after some time. So suspension can be like this. So after some time at the bottom, we can see the solute particles. Then foam is basically characterized by the gas bubbles dispersed in a continuous liquid phase. So this is the liquid phase, basically continuous liquid phase. In that, these are the air bubbles will be there, which we can see like these. So like in the whipped cream or the meringue, or it basically provide a light and the airy texture it used to provide. To produce foam, energy supplied basically, or whipping is being done to introduce gas into the liquid, to break the large bubbles into the smaller one, and to spread the liquid phase around gas bubble. So like this will be air bubble and liquid will be at the above, and like this the structure will be there. And forming agent will be, you can see at the interface. So gas bubble will be there, then some forming agent can be there, so that the surface tension can be uniformly distributed, and then after that liquid will be there, so that to form the stable system. Then gel is basically like this. So it's basically a semi-solid structure which is formed by 3D network of polymeric chains in which liquid is trapped, and it can seen in jellies or gelatin deserts, and it retains high moisture content. It exhibits both the flow resistance and mechanical rigidity. So it basically creates from protein polysaccharides based ingredients through cross-linking. So gels are basically semi-solid structure, and foams are basically dispersed gas bubble in the liquid, and suspension are solid particles in the liquid medium. So C answer is correct here. Okay, let's see this question. Which of the following improves the stability of mayonnaise? Acids and emulsifiers, emulsifiers and the stabilizers, sugars and stabilizers, then anti-caking agents and emulsers, emulsifiers. I'm so sorry. Oh, maybe I misunderstood with your previous question. Maybe it's okay, Jitendra. The answer is C. Okay, so now this is Lakshmi B, Fozia B, Satyam B, B, emulsifiers and stabilizers. Jitendra B, okay. Gautam also B. Everyone is on same page. So emulsifiers and stabilizers is the correct answer. So emulsifiers basically improves the stability of the emulsions like mayonnaise, and it reduces the surface tension between oil and water, so preventing the separation. So mayonnaise is basically a oil in water emulsion, right? So continuous phase is water and the dispersed phase is oil. So oil in water emulsion. So here basically stabilizers we use which enhance the emulsion stability by thickening the continuous phase, ensuring the emulsion remains homogeneous over the time. Whereas this acidity or acids we use to affect the pH, and it affects the texture of mayonnaise but doesn't directly stabilize the emulsion. And sugar, it also increases the viscosity, but it doesn't provide the necessary emulsification property like stabilizers. And the anti-caking agents basically used to prevent the clumping in the dried products and have no role. Ankit C, Gautam C, Tiwari, Ankit Tiwari C, proteases. So many of us are saying C, proteases. Which among the given enzymes can catalyze hydrolytic reaction in proteins? This is proteases, which is correct answer. All of you are correct. So proteases basically are the enzymes that especially break down peptide bonds in proteins and forming the smaller peptides or amino acids. So amylases, this lipases and cellulases, they are basically amylases for the carbohydrates, lipases for the lipids, and cellulases for the cellulose. For like proteases can be two types, endopeptidase and exo. So in endopeptidase or protease, what happens if like this is the chain, so it breaks the chain from inside, like, and exopeptidases basically, these are basically the hydrophobic amino acids, and it breaks from this these are linked between the chains, and it break uh, from these amino acids, hydrophobic amino acids is break the bond and form the peptides. And in exopeptidase, is basically these hydrophobic groups are at the end. So it removes these groups, and it then breaks the chain. So endopeptidase includes like trypsin, chymotrypsin, and it's like site of action is within the protein chain, and it forms a large peptide fragments, whereas exopeptidase, it is like amino peptidase or carboxypeptidase, and at the end of the chain it starts breaking, and it form individual amino acids or dipeptides. So basically the mechanism is like one is it can be nucleophilic attack or transition state stabilization. So in nucleophilic attack, nucleophilic amino acids, residues like serine or cysteine in the active sites attack the carbonyl carbon of peptide bond to form tetrahedral intermediates, and in transition state stabilization, basically enzyme stabilize intermediates and facilitates the bond breakage of peptides. These two kind of actions it may take depend on which enzyme is there. So next is, which of the following factors significantly influence the rate of hydrolysis process? Temperature, pH, and water activity. Okay, let's see. So Ankit is saying D, Husya is saying D. D means 1, 2, and 3, which means pH, temperature, and water activity. Okay, so let's see the answer. So you guys are correct. So the rate of hydrolysis is basically affected by the temperature, pH, and water activity. So this is the hydrolytic reaction where B is reacting with water, and A is like this is going with H, and B is with OH. So the temperature basically affects the kinetic energy of the molecules. So higher the temperature, so it increases the rate of the reaction by providing the necessary energy to break the bond. So if there is high hydrolytic process or hydrolytic rate of hydrolytic reaction will be higher at higher temperature. But if there is excessively higher temperature, it may denature the enzyme. So it can slow down the enzymatic hydrolysis process. For the pH, if we see pH basically play a crucial role in the activity of the hydrolytic enzymes and the reactivity of the substrates, because different enzymes have their optimal pH range, and if we are deviating from these range, it can reduce the enzyme efficiency, or it may also denature the enzyme, which inhibit the hydrolysis process. Like pepsin, if we see, it works best in the acidic condition, where trypsin, it works in the alkaline conditions. And water activity is essential because hydrolysis involves the interaction with the water, with the chemical interaction of water with the chemical bonds. So if water activity will be low, so it can slow down or it can prevent the hydrolytic reactions, which is why drying is basically commonly used for the preservation techniques. Also, apart from these, texture changes if the texture of the food can also affect the hydrolysis process, such as hydrolyzed proteins. They can lead to a softer texture in the meat. Also, the flavor development, basically hydrolytic reactions basically can produce the flavorful compounds like the basically these basically starting parameters are the controlling parameters like temperature, then pH, and water activity. Now we are discussing here that the type that what hydrolysis can do. So hydrolysis can basically change the texture of the basically food product. So it may produce the softer texture in the meat. Also, it can produce basically the flavors such as the savory flavor from the amino acids or the sweet flavors from the sugars. In the production of hydrolyzed vegetable proteins, proteins basically are hydrolyzed into the amino acids and smaller peptides, and it can produce savory flavors which can used in the seasonings. And this hydrolysis process basically it affects the nutritional content also, so it can also improve the digestibility, and it makes the nutrients more susceptible, and because it converts the starch into simple sugars, and it will be easily digestible. Starch also it gelatinized starch. So basically during cooking, water and heat, it force the starch granules to swell and undergo hydrolysis, breaking down this glycosidic bond and form the gel. So this is basically used in the starch gelatinization process, also in the retrogradation process. So when upon cooling, basically the hydrolyzed starch, it can reassociate and leading to the firm texture. So retrogradation basically is also the cause in the staling of the bread. And the cheese ripening also, we can see hydrolysis like proteolysis and the lipid hydrolysis, where cheese can undergo proteolysis, like the casein proteins can hydrolyze with the help of proteases, and the texture and the flavor can change. And lipid or hydrolysis, basically lipases break down the milk fat into the free fatty acids, and it can contribute to the aged flavor of the cheese. So like this, if we see in the lipids, basically the triglycerides, these are the triglycerides, they are undergoing the hydrolysis, and they can form basically glycerol and fatty acid salts. And this is the protein acid hydrolysis, basically in the protein. So it can form like it can break this peptide bond and form the amino acids, different amino acids. And in glycosidic, basically acid hydrolysis, it breaks down the glycosidic bond in the starch, cellulose and hemicellulose, and convert it into the basically monosaccharides. So mainly affecting parameters are temperature, pH, and water activity in the hydrolysis process. So which of the following characteristics of food are affected by pH? Flavor and color, color and texture, texture and flavor, and flavor, color, and texture. Anyone who would like to answer this question? D, flavor, color, and texture, which is correct also. So pH basically influences wide range of the food. So basically pH influences the rate of the many reactions, and it affects the rate of many chemical reactions and many enzymatic reactions. So it affects flavors as acidic or basic environments. They can change the taste profiles, making foods more sour or bitter. It also affects the color because it affects the pigments like anthocyanin, which shifts its color based on the pH, and texture also it affects because there can be a change in the protein structure or water holding capacity, so which can affect meat and gels. And extreme pH, they can lead to severe inhibition of microorganisms growth or some enzymatic processes, so which can basically lead to the different reactions, can also lead like the acceleration of acid and basic catalyzed reactions can also occur. So it basically pH in short, it basically affects the different like pigments, and it affects the protein structures. So it can also it can provide the like condition for different chemical biochemical reactions to take place. So it affects the flavor, color, and texture of the food. So pH, if we see the water holding capacity and the tenderness of the muscle foods, so basically they are improved at acidic conditions, and below the typical pH of the post mortem. So basically if pH is around 6, so it will be dark, firm, and dried. meet, but at 5.6 it will be normal, but at the low, very low pH it will be pale, soft and exudative. So based on the pH, basically the water holding capacity or the tenderness and the meat, they both going to affect. So during the processing of the food, pH values, it affects various processes and the phenomena such as protein properties like denaturation, jellification, enzyme activities, growth of the or the mortality of the microorganisms, and the germinations and the inactivation of bacterial spores, and many reactions like Maillard reaction. So that way it is going to affect the sensorial property of the food product. Okay, let's see this question about water activity. Which of the following is not a factor that significantly influences water activity in the food? Temperature, enzyme concentration, physical state of food, and type of packaging material. So we all know that water activity is basically the ratio of the vapor pressure of the food divided by vapor pressure of the distilled water or uh, like the pure water. So P by P naught is basically water activity. And if we convert it into equilibrium relative humidity, so water activity into 100 is relative humidity. So we need to tell here which of the parameters which not will going to not affect the water activity. B, enzyme concentration. Okay, let's see. Yes, so enzyme concentration will not affect. So water activity basically is affected by the availability and mobility of water in the food matrix. So temperature basically affects the water activity because it influences the distribution and energy of water molecule, potentially increasing the reaction rate and microbial activity. And physical state of the food is very important, like as it change from solid to liquid or gel and can alter the water distribution and availability. So in gel and in solid and liquid, water distribution is very different. Then type of packaging material. So it affects water activity because it either prevents or allow moisture to exchange between the food and the its environment or the surrounding. Whereas the enzyme concentration, it doesn't influence directly water activity, but enzymes may catalyze reaction in the food that indirectly affect the quality of the food, but they directly do not affect the availability or mobility of water. So we have the new, like, water activity basically affects various reactions rate like enzyme catalyzed reactions, lipid oxidation, non-enzymatic browning, sucrose hydrolysis, and pigment degradation. And most reactions, they tend to decrease or slow down below water activity of around 0.75 to 0.85. Oxidation of the lipids and associated secondary effects such as the like carotenoid decoloration, they can undergo at lower water activity also. Their reaction can undergo, like based on the water activity, how much water activity is there, so they can we can have the relative reaction rate. So what, how much reaction, which reaction is happening. So enzymatic reaction activity is happening even at low water activity. So there are lipid oxidations, non-enzymatic browning, and hydrolytic reactions. They will undergo even in the, like, they will undergo even after zero point 0.3 water activity to zero point 0.8, they will undergo at around 0.6 to 0.7. The hydrolytic reaction or the lipid oxidation or the non-enzymatic browning, all reaction will easily can take place. So enzyme concentration is the answer here. Next is that we have the given statement. We need to tell which one is correct with respect to water activity, water content, and glass transition temperature. So statement 1 is saying that Tg is unrelated basically to water content in foods. Second, water content at Tg affects diffusion limited reactions in frozen and dried foods. Third is water activity influences the rate of chemical and enzymatic reactions in foods. Shivaswamy B, Fozia also B, only 2 and 3. Jitendra also. Okay, let's see the answer. So only 2 and 3 is the correct answer. So basically Tg is closely related to water content in the food. So water is basically, Tg is glass transition temperature, right? So water basically it is affecting as plasticizer. So it is lowering, it is lowering the Tg of the food. So and it is affecting the physical properties of the food. So Tg is basically closely related to the water content in the food because water content is acting as a plasticizer. So this one is incorrect. Then water molecule basically it insert between hydrophilic biopolymeric chain like the starch chain is there, amylose and amylopectin will be there. So it will go, or the gluten or the protein chain will be there. So water will go and insert in between these chain. So it will weaken hydrogen bonding and dipole interactions, which lowers Tg and shifts the food matrix from a glass is the rigid glassy state to a rubbery one. So since Tg is low, so from glassy to rubbery state, the shift will be there. So for instance, in wheat gluten films, if Tg drops significantly as water mass fraction increases, so water if increases, so Tg will decrease. So there will be, it can correlate with the mechanical and the barrier property. So what we can see is if Tg is less, so it means that the uh, substance will going into more rubbery state because water is acting as a plasticizer here. Water content at Tg, it influences diffusion limited reactions such as the crystallization reaction or the recrystallization or the gelatinization or the starch retrogradation in frozen and dried products. So water activity, because water is here limited available, right? So it produces diffusion limited reactions, and water activity affects basically the rate of reaction and both the chemical and the enzymatic. So it can accelerate or deaccelerate the reaction based on the water activity, as we saw this chart here, that based on the water activity, the if low water activity will be there, so that these reactions will not take place at fast rate, but when water activity is near 0.8, the reaction rate will be very high. So water content at Tg, it affects basically diffusion limited reactions in frozen and dried products, which is correct. And water activity influences the rate of chemical and enzymatic reaction in the food, which is also correct. Okay, let's see this question. Modified atmosphere packaging, it helps extend the shelf life of the food by maintaining the level inside the package. So it increases the oxygen and reduce CO2, or it increases the temperature and decrease nitrogen, or it reduces the oxygen and increases the CO2, or it increases the respiration rate by reducing the nitrogen. So which one would be correct for modified atmosphere packaging? Also, please let me know what is the difference between controlled atmosphere packaging and modified atmosphere packaging. Okay, so maximum are saying C, that reducing the level of O2 and increasing the CO2, which is correct, that we are reducing the level of O2 and increasing the level of CO2. But please let me know what is the difference between MAP and CAP. So in modified atmosphere packaging, we are increasing the shelf life of the food product by decreasing the level of oxygen and increasing the CO2 in the food package. So when we are decreasing the O2 level, so the respiration will slow down and microorganism rate, growth rate will also slow down, and we can adjust CO2 level so it can inhibit the spoilage microorganism growth. So in controlled atmosphere packaging, basically constant oxygen and CO2 levels is tried to maintain. So in MAP, basically it focuses on the gas composition and it doesn't concentrate on the temperature regulation. So temperature regulation is not correct. Also, the nitrogen is used to displace the oxygen. The key to but the main uh, ingredients or main reason for effectiveness of MAP is the combined use of the or modification of the oxygen and CO2 levels. Like we have these food products, so there will be O2 and CO2 control level. So based on that, we can have the increased shelf life. Like these are the system where we are maintaining O2, CO2, and N2 level, and you can see it can increase the shelf life. So there are different. This table is indicating different food products, and they can have different O2 and CO2 levels here. Like the modified conditions of O2 and CO2, so to increase the shelf life. In controlled atmosphere packaging, basically, so in this question, basically answer is C, reducing O2 and CO2 level. So Shivasamy is saying that modified atmosphere packaging, gas concentration altered, and controlled atmosphere gas composition altered. Both gas composition altered, composition and concentration. Oh no, actually in controlled atmosphere packaging, we continuously measure. If we maintain, like suppose 5% of oxygen and some suppose X% of oxygen and Y% of CO2. So in controlled, we continuously monitor and control the gas composition. Whereas in modified atmosphere packaging, once we maintain the condition, we're not going to continuously monitor and control that particular atmosphere. We first modify and then it will be based on we will not going to continuously monitor or control this condition. So next is which of the given options are considered primary factors affecting the stability of vitamin in food during processing: light exposure, fat content, enzyme concentration, and mineral presence. Vitamin degradation or stability, which one is related to that, which is related to like which is affecting the stability of vitamins. Only one. And Shivaswamy is C1 and 3. Okay, so let's see. C is correct here. So basically, light exposure is affecting the vitamin stability. As we know that UV light degrades vitamin C and riboflavin. So this is ascorbic acid. So UV radiation, if it's there, so it will going to degrade vitamin C amount. So that's why food is being packaged in the dark conditions or the dark containers so that to prevent the light exposure. Enzyme concentration is a second crucial factor which affects the which acts as a biocatalyst and it will break down the vitamins. So we use basically the blanching process so we can inactivate these enzymes so we can preserve these vitamins, right? So we can see here different enzymes are there which are like converting these into different products. So basically two things which is the enzyme concentration and light exposure will going to affect. Whereas the fat content basically only affect the fat soluble vitamins like A, D, E and K, but not all the vitamins. So it's not the primary factor for the stability. And minerals, they basically have a little impact on the vitamin stability, where they are basically stable, catalyze the vitamin degradation. They are only, they are significantly important, otherwise they are not important minerals about the vitamin degradation. So basically two factors are important, light exposure and enzyme concentration. So 1 and 3 is the correct answer here. Okay, let's move to this question. Which of the given statement are correct with respect to the effect of temperature on enzyme activity? So statement 1 is saying enzyme activity it increases with the temperature up to a certain point, after which decreases due to denaturation. Second is most enzymes are completely inactivated at temperature greater than 50 to 55 except for thermostable enzymes like peroxidases. So this is very simple question. Both A and B. Okay, guys. Both in A and B. So enzyme activity basically it increases when the temperature increases because it increases the kinetic energy of the molecules. So it which enhances the frequency of enzyme substrate collision. So rate of the reaction it doubles every 10-degree rise in temperature. Beyond optimal temperature range like 30 to 40 degrees Celsius, enzyme activity will going to decrease sharply because of enzyme structure will going to start denature because it's a protein, so it loses its functionality based on its shape. So this denaturation is basically irreversible. So it results in breakdown of the enzymes secondary and tertiary structures. The most enzyme completely they inactivate above 50 to 55 degrees Celsius except for the thermostable enzymes like peroxidases. So others will undergo extensive structural damage and lead to the loss of the enzymatic function. These enzymes they have evolved to basically this thermostable enzyme they retain their structure and they'll be active even at the higher temperature, so it will be suitable for industrial application even at high heat stable enzymes. So we can see with the temperature enzyme activity increases after the optimal temperature, when the enzyme denature activity decreases. So we can see in the pasteurization of the milk, we do at 63 degrees Celsius for 30 minutes so that we can deactivate this enzyme. We can denature this phosphatase enzyme. In blanching, we boil the water, right, to inactivate polyphenolase and lipoxygenase and chlorophyllase and ascorbic acid oxidase so that spoilage will not be there. So we inactivate to heat at higher temperatures. So answer C is correct here, that the both statement are correct. Let's see this question about starch debranching enzyme hydrolyze. Basically dash bond. Which bond is hydrolyze, enhancing the efficiency of starch processing? Most of us are saying C, alpha 1,6 glucosidic, and one is saying also A, which is beta 1,4 glucosidic bond. Okay, let's see. C is correct. So starch basically composed of two basically monomers. One is amylose and another is amylopectin. So amylose, it is basically a linear chain. This is a linear chain which is known as amylose. So it is basically linked with alpha 1,4 glycosidic bond. And this amylopectin is basically here is branched. This branch is basically um, attached with the help of alpha 1,6 glycosidic bond. So when the starch debranching enzymes like isoamylase or the hulunase, they will basically target this alpha 1,6 linkage between the two glucose residue. So this branching points they will attack. So hydrolyzing these branches point, it increases the efficiency of starch processing by breaking down the complex branch structure into simpler structures. So more linear forms will going to get, which can be easily converted into sugars and other products. So if branch chain will be broken down, then it will be easy to convert these linear chain into further simpler products and to get the to convert these sugars. So basically, this is the amylo and amylopectin chain. So it may undergo like this fullinase and isoamylase, and it leaves basically alpha 1,6 glycosidic bond in amylopectin. So we can get amylose here. If glucoamylase or beta amylase will be there, it will cleave both alpha 1,4 and alpha 1,6 glycosidic bond, and we can get glucose basically. If alpha amylase is the enzyme, so we can cleave this alpha 1,4 glycosidic bond and we of both the amylopectin and amylose. And if cyclodextrin is there, so it is going to cleave alpha 1,4 glycosidic bond uh, of the donor molecule and transfer part of the donor to a glycosidic acceptor. So it is going to form some cyclic structure. So here answer C is correct, 1,6 bond. Okay, so guys, we covered today basically the different chemical and biochemical reactions in the food. So we discussed about caramelization, Maillard reaction, we discussed about lipid oxidation, and we discussed about Arrhenius equation and when it's not like it's deviated. So after that, we discussed about different pigment decoloration, and we discussed about enzymatic browning, ascorbic acid oxidation or the vitamin degradation we discussed. Then we discussed lipids oxidation and the protein degradation, different enzymatic and non-enzymatic reactions, and we discussed about hydrolysis, then we discussed about lipids and its hydrolysis, and then we discussed about the different parameters like temperature, pH, and MAP, and light and water activity, and it's affecting the food, how it's affecting in the food. and then we discussed about the concentration, pH, and temperature of the enzymes, which is affecting the different biochemical reactions. And at the end, we discussed about the starch debranching process. And in the next class, we'll be discussing about significance of sensory organs, and then anatomy and function of taste and smell, then sensory evaluation or methods, and psychophysics of sensory perception and novel techniques in sensory evaluation. So next week we'll mostly be discussing about sensory properties. So I'll be uploading video on my YouTube channel, and PPT I'll be sharing on Google Drive link. So if you have any question, please post on Q&A. Thank you so much for joining the class, and let's meet on next Sunday, 4 to 6. Thank you so much for joining the session. And if you have any doubt, you can please stay, and otherwise you can leave the meeting. Ankit, thank you so much. Shivasami, thank you. So I'm stopping the recording now.